let's talk about adding and subtracting. This is where things can get kind of messy, but they could also be actually very nice. If I were to take 5 and 2/7 plus 8 and 3/7. Understand that when the whole number is next to the fractional part, it's understood that there's addition here, right? So you could really look at this as, I'm going to put my little thought bubble, you could really see this as 5 plus 2/7 plus 8 plus 3/7. If I were to look at it that way, what would you do here? Wouldn't you combine the like terms that you have? Because 5 plus 8 is just 13. And then what about the fractional pieces if you combine 2/7 and 3/7? So that's 13 plus 5/7. Do y'all agree? But you could just write this as what? 13 and 5/7. So here's my little thought bubble. This is what I know about mixed numbers. Do y'all agree? Now, a lot of times if you see a problem like this, this was the way that I was taught, this is the way I still do it because it's a lot easier, I think. If you line this up like columns, and you add the fractional pieces, 2/7 and 3/7 is 5/7, 5 plus 8 is 13. The problem's done. If you look at what they ask you to do in the textbook, they want you to convert each of these guys to an improper fraction. You can do that. Now, read the textbook and you can find out that if you do that, that's fine. And you'll still get the same answer. But I think it causes us more pain than it's really worth. Yes, what's your question?
The rewrite of the problem. Doesn't it make that a different problem again?
Does it make? Is this different? Is that what you were asking?
I mean, if you look, yeah.
No, because understood to be between here is addition. 5 whole pieces plus 2/7 of another piece. So I haven't changed the problem. The meaning is still the same. If I look at it this way, though, I know that it's a lot easier for me to combine the whole pieces, and then I can combine the fractional pieces.
Yeah, okay. Yeah, 5 to 7 plus 8 to 7. Okay.
Yeah?
That's a problem.
Yes.
But just cover that up.
This?
No. This side.
This?
Yeah. So 5 plus 2 7 plus 8 plus 3 7.
Yes.
That
It's addition, so the order doesn't really matter, right? Right? So if I can add the stuff I know how to add, 5 and 8 is 13. And then these guys have the same denominator, so it's 5/7. And I understand that 13 whole units plus 5/7 gives me 13 5/7. That was too easy. I think that's what it was. It seemed too easy to be true. And you're going, I know that things can get much happier than this. So I agree with you. If I have 7 and a 12th, okay, plus, let's say 4 and, what sounds good?
12.
Really? Really? I'm going to ignore that. 4 and 3/8. Let's do that. Now I'm going to show you the way that I was taught, the way that I still do this. I know that if I want to combine whole pieces like the 7 and the 4, I can do that, and that's easy. But when I have to combine the fractional parts, I have to do what? Find the common denominator. And we've done this, right? Now, here's my problem, and typically what I do is that I rewrite this. So I rewrite to say 7 and 1/12 plus 4 and 3/8. This is what I do. And then off to the side, I'm going to write what those equivalent fractions will be. So what's the common denominator for 12 and 8? You could use 24, which is the right answer. I don't know what I was thinking. I'm sure I'm glad that you guys are here today. I've been making all kinds of mistakes. It's a good thing this isn't being recorded. So how do I go from a 12 to a 24? What was the factor that you multiplied at times? So you multiply this guy times 2, so I need to do the same thing in the numerator. So 1/12 is the same as 2/12. Do you all agree? And then what about 3/8? What do you multiply that? What was the factor that you were missing here? 3. So 3/8 becomes what? 9/24. Do you all agree with that? So 2/24 and 9/24 is how much? So this is 11/24. And what's 7 plus 4? It's 11. Now that wasn't too bad, was it? Of course, we have to know how to get common denominators, but you guys know how to do that, right? Like a boss. That's what I'm talking about. Now, I know you guys want to do another one, right? So I gotta make sure that I'm feeling this. Okay, well, let me do this. How about 10 and 5/6 minus 2. Oh, because I said minus, you guys get huffy with me? Goodness sakes alive. Let's say 2 3/5. Remember, I do everything out of love. I mathematically love you guys so much. The math just pours forth from my heart. All I need are some willing sponges to soak up the math. Now, I don't like the way this is written, so I'm going to rewrite this. 10 and 5/6 minus 2 3/5. If I had to estimate this, guys, 10 and 5/6 is about what? You'd say about 11. 2 3/5 is about what? It round to 3, so what's 11 minus 3? 8. So in the 8-ish range, right? Well, I need to get common denominators. Oh, that's not a problem for me because I'm an LCD champ. And when we say LCD, we're talking about least common denominator, not liquid crystal display. So, do 6 and 5 have a common factor? Back up. Do 5 and 6 have a common factor? Is there something that goes into both of them? No, the only thing that goes into both 5 and 6 is 1, right? So they're relatively prime, which means the LCD is just 6 times 5, which is 30. Now, how did I go from 6 to 30? I multiplied times what? 5, so it's 5/5, so I end up with 25/30. And what was the missing factor for the 5 in the other fraction? 6, so I have 18/30. Do you all agree? Now, what are we doing here? What's the main operator in this problem? Subtraction. So 25 minus the 18 gives me what? So that's 7/30, and 10 minus 2 is what? 8. How did I estimate? I estimated my answer to be what? 8. 8 and 7/30, isn't that about 8? It would even round down to 8, so yeah, I feel good about this. What do you guys think? Is it crazy? When I do it in the column format, I add or subtract the whole pieces, and then I add or subtract the fractional pieces. Just straightforward like this, right? But I know what you're thinking. I thought there's some weird stuff that happens with these problems. You're right. We're going to find out after the break.